Okay, in this video we're going to be talking about solving quadratic functions. Okay, so solving quadratic functions is basically where we're finding the roots, the zeros, or the x-intercepts. So we're finding an x equals answer to figure out where it's crossing the x-axis. Quadratics, remember, are parabolas, so we're basically taking this full unit and graphing them, finding different ways to find their x-intercepts, and making their equations. Okay, so one real solution would be if you have x equals one number, it only crosses your x-axis once. Two real solutions, you'll have x equals two numbers, where it's crossing your x-axis twice. No real solutions means you don't have x equals a real number, and it would be floating above that x-axis. Okay, standard form is what we're going to be working with in this one. So ax squared plus bx plus c, so it goes x squared, then x, then your number. Vertex form is what we have been graphing with, where we found our hk as our vertex, and then we graph them there. Okay, so zero product property for solving for any real numbers so that a and b equals 0 when you multiply them. So product means to multiply. 0 means it's what gets me 0. Okay, so ZPP, what you're end up doing is you're going to take both, after you've factored it, both sets and set them equal to 0. And then you're going to solve. So this one I would subtract 5 and get x equals -5. I would add 7 and get x equals 7. The reason that we do this by setting them equal to 0, because if I plug it back in here, times x minus 7 equals 0. -5 plus 5 will get me 0. 0 times anything is going to get me 0. So we're figuring out what my x-intercepts are, because anytime on my x-axis, my y will always be 0. So we're solving those x's to figure out that this u would cross at -5 and 7. So my zero product property, we're finding the zeros by doing the product of what we factored. Okay, so my first job is to move everything over to one side and keep that x squared positive. So we're going to subtract him over to get x squared minus 6x equals 0. And then we're going to factor normally. So remember, whenever we're factoring, we try to find the GCF first. So they both have an x in common, so he'll sit on the front side here. X squared divided by x will give me x. These ones will cancel. Once I've fully factored, I do my ZPP. Set this one equal to 0. Set this one equal to 0, and I solve. Luckily, I only have to solve one in this. So if I graphed this parabola, x squared minus 6x, it would cross at 0 and 6 on my x-axis. Okay, my next one, I got to subtract that 15 over. I got 2x squared plus 7x minus 15 equals 0. There's no GCF, so I'm going to have to send that 2 back and get -30. So what multiplies to -30 adds to 7, and it is going to be a +10 and a -3. Okay, don't forget to divide by what you sent back. So I need to divide by that 2 to get x plus 5, and then I can't simplify that fraction, so I'm going to bring them forward. Once I've fully factored, now I can figure out my x-intercept. I do my ZPP. X plus 5 equals 0. 2x minus 3 equals 0. So I subtract 5 to get x is equal to -5. I add 3, divide by 2. So x is equal to 3 over 2. So it would be crossing at 1.5, or 3 over 2, and -5. Okay, my next one here, everything's on the correct side. It's all in order. It goes x squared, x, then my number. There's no number to send back, and there's no GCF, so what multiplies to 64 adds to -16 is going to be -8 and -8. I only really need to set one of them equal to 0 because they mean the same thing. So I would add 8 and get x is equal to 8. So this would be just touching the 8 on that u. Okay, my next set, the square root property. If I just have x squared and no other x, I'm not going to factor. I can just solve it. Okay, so if you want to write in your notes, if there's no other x, if it's just an x squared, we can solve it. So I'm getting x by itself, so I'm going to add 49. Opposite of squaring is square rooting. So x is going to equal the plus or minus 7, the positive 7 and negative 7. Because it's a U shape, you have to have the positive side and the negative side. So my next one, we're going to add 81. Opposite of squaring is square rooting. So I'm going to get plus or minus 9. My next one, we got to add 128. Get rid of the things not attached to it first. Then get rid of the thing that's attached to it. So x squared equals 64. Opposite of squaring is square rooting. So plus or minus 8. Okay, perfect square trinomials. Tri means 3, so now I've got 3 terms. So to be able to do this, I look at the back end and the front end number. If they are perfect squares, so if I can find 2 numbers that are the same, that multiply to get me that, I can do this shortcut. Okay, so the 2 numbers that are the same to get me 25 are 5. Since it is a plus plus, I need a plus plus. And then my 2 things to add that multiply to get me that 1 or that x up there is going to be x. Okay, if you think about it, what multiplies to 25 adds to 10 is going to be that 5 and 5. Okay, a perfect square trinomial, I can write it as a squared. That's why it's called perfect square trinomial. And it's not equal to 0. It's equal to 49 here. Okay, because I can keep solving, I don't want to rewrite it out and FOIL it because then I get back to square 1. So since everything's underneath that squared, I'm going to get rid of it by square rooting. So I just have x plus 5 equals plus or minus 7. Okay, so then I can subtract this 5. I got x is equal to negative 5 plus or minus 7. And then I'm going to go into the split. So negative 5 plus 7, negative 5 minus 7. Okay, because it means a positive and a negative side of it. So negative 5 plus 7 is 2, negative 5 minus 7 is negative 12. Okay, my next one. Multiplies to 49, that's the same number as 7's. But to get it to be a negative 28, I need them both to be negative. Okay, because it'll multiply to get me that positive, but when I add it gets me negative, and then perfect square of 2 or 4 is going to be 2. So I've got 2x minus 7 squared is equal to 5. Opposite of squaring is square rooting. So 2x minus 7 equals plus or minus the square root of 5. Since it's not pretty, we're going to go ahead and add 7. You can add that 7 to the back end or the front end. I like to put it in the front end. And then we got to divide everything by 2. So x equals 7 plus or minus the square root of 5 over 2. Okay, my next one here, we got perfect squares in the front end and back end again, so I'm not going to subtract the 11 over. So I need 5's in the back end. It's a plus plus, so I'm going to leave it a plus plus. And 2 numbers that are the same that get me 9 are 3x. So I've got 3x plus 5 squared is equal to 11. Opposite of squaring is square rooting. So 3x plus 5 is equal to plus or minus square root 11. We got to subtract the 5, so I'm going to put them in the front again. You could put them in the back. Make sure the plus or minus stays with the square root. And the negative stays with that 5. Then divide everything by 3. So x equals negative 5 plus or minus the square root of 11 over 3. Okay, my next one here. Multiplies to 9 are 3's, but when I add them I need a negative 6. So they both have to be negatives. I got a normal x squared in the front, so we're just going to write a normal x. I got x minus 3 squared equals 32. Opposite of squaring is square rooting. So x minus 3 equals, I need to simplify this radical. So I'm going to do my radical jail here. So first I do my factor tree. So 2 things that multiply to get me to 32. I could say 8 and 4. I could break 8 to 4 and 2, and 2 and 2, 2 and 2. I'm going to take all of those that are broken down. So 1, 2, 3, 4, 5. There are 2, 3, 4, 5. Okay, so radical jail, you have to have a buddy to escape jail. That's the same. Okay, in the process, one will escape, but the other one will die. So I have two 2's that escaped, and the one that was left that wasn't circled or crossed out is a 2 in there. 2 times 2 gets me 4. Okay, so this is now plus or minus 4 square root 2. And then I just have to add this 3. We're going to go ahead and put them in the front end. Like this. Okay, my next one here. 16, I need a 4 and a 4, but I need a negative, so we make them both negative. And then to get me that 9, I need a 3x. So 3x minus 4 squared equals 2. Square root them. 3x minus 4 equals plus or minus the square root of 2. Add 4. Divide all by 3. So 4 plus or minus the square root of 2 all over 3. Okay, my last one here. Got x's in the front because there's nothing up there. I need multiplies to a positive 16 but adds to a negative 8. So I need negative 4 and negative 4. So x minus 4 squared equals 19. Opposite of squaring is square rooting. So x minus 4 equals plus or minus the square root of 19. Go ahead and add 4. So 4 plus or minus the square root of 19 is where it's going to cross at. So a decimal again.